Welcome to qnawire.
Okay, so for the first question, let's say that O is the center of a sphere. So we know OA is equal to OB is equal to OC, which is equal to R. We know theta AB is equal to theta BA, and theta RB is equal to theta AC. And theta AB is equal to theta BA is equal to theta RB. So therefore, we have theta AC is equal to theta BA. We have also known that theta AA is equal to theta BA, and theta AC is equal to theta BC. So therefore, we have theta BC is equal to theta AA. So for the next question, so the angular deflection at point A should be equal to theta AA minus theta BA. And the angular deflection at point B should be equal to pi minus 2 theta AB. And we know theta BA is equal to theta AB. So therefore, have the angular deflection at point B is actually equal to pi minus 2 theta BA. And we also know that the angular deflection at point C is theta BC minus theta AC, which is equal to theta AA minus theta BA. So therefore, we have the total angular deflection, which is delta here, is equal to theta AA minus theta BA plus pi, and then minus 2 theta BA plus theta AA minus theta BA. This will give us delta is equal to 2 theta AA minus 4 theta BA plus pi. And for question C, we know N, which is the refractive index of the water, is equal to sine theta AA over sine theta BA. And we know sine theta BA is equal to sine theta AA over N. So therefore, we have theta BA is equal to arcsin sine theta AA over N. And as you can tell, we can use the arcsin sine theta AA over N substitute for the theta BA. So eventually, we have delta is equal to 2 theta AA minus 4 arcsin sine theta AA over N plus pi. So for the question D, well, we know d delta is over dA over d theta AA is equal to 0. So therefore, we also have d delta over d theta AA is equal to negative 4n cosine theta AA over n times square root minus sine square theta AA plus n square plus 2. As you can tell, n and n can be cancelled out. So this will give us negative 4 cosine theta AA over square root negative sine square theta AA plus n square plus 2 is equal to 0. So say that theta AA is equal to theta 1. So we have negative 4 cosine theta 1 over square root negative sine square theta 1 plus n square is equal to negative 2. So therefore, we'll have cosine theta 1 over square root negative sine square theta 1 plus n square is equal to 1/2. So we have cosine theta 1 is equal to 1/2 times square root negative sine square theta 1 plus n square. And we know sine square theta 1 can be equal to 1 minus cosine square theta 1. So if we put square on each side and use 1 minus cosine square theta 1, substitute for the sine square theta 1, we'll have such equation here, which is cosine square theta 1 is equal to 1/4 times negative 1 minus cosine square theta 1 plus n square. And then we'll have cosine square theta 1 is equal to negative 1/4 plus 1/4 cosine square theta 1, and then plus 1/4 n square. And then we can move the 1/4 cosine square theta 1 to the left side. Then we have 3/4 cosine square theta 1 is equal to negative 1/4 plus 1/4 n square. As you can tell, we can multiply by 4 on each side. And this will give us 3 cosine square theta 1 is equal to negative 1 plus n square. So eventually you have cosine square theta 1 is equal to 1/3 times n square minus 1. For the last question, we know that refractive index of water for violet lights is equal to 1.342. So therefore, we have cosine squared theta 1 is equal to 1 over 3 times mv squared minus 1. So eventually, we'll have angle theta 1 is equal to 58.87 degree for the refractive index of water for violet light. And then we know that the refractive index of water for red light is 1.330. If we plug in to calculate the angle theta 1, eventually we'll have theta 1, which is equal to theta AA, is equal to 59.60 degree. So now let's take a look at the total angle deflection at angle 58.87 degree, and the refractive index is equal to 1.342 at this point. So eventually we'll have the angle is equal to 139.2 degree for the violet light. So, but the actual angle should be equal to 180 degree minus 139.2 degree. Okay, it's because that we know in the real case the angle is not larger than 90 degree. So we need to use 180 degree minus 139.2 degree, which will give us 40.8 degree for the violet light. Okay, and for the red line, we'll have the total angle deflection is eventually equal to 137.5 degree. But the actual angular deflection should be equal to 180 degree minus 137.5 degree, which is equal to 42.5 degree. And the reason is the same with the previous one. So therefore, the actual angle for the red line is equal to 42.5 degree. So since we know the actual angular deflection of the red line is greater than the actual angular deflection for the violet light, therefore the red color is higher above the horizon. Okay, and these are the answers for this question.